Today, we're going to pull back the curtain on something kind of magical. It's this quiet, almost invisible process that makes our digital world just a little bit faster, a little bit better every single day. I mean, think about it for a second. You use an app all the time, right? And then one day, there's an update, and suddenly, it just feels snappier. Things load a little quicker. The animations are smoother. You didn't buy a new phone, so what actually happened? Well, it's not a happy accident, that's for sure. It's the result of a lot of hard work, not just from developers, but from a special kind of program that acts like a silent partner in the whole process of making software. And that silent partner's job has a name: optimization. It's this fascinating art within computer science of making code not just work, but work beautifully and incredibly efficiently. So you might be thinking, okay, cool, but why does this matter to me? It sounds like something only programmers need to worry about, but really its effects are everywhere in our lives. The benefits are things you can actually feel. When code is more efficient, it uses less of your phone's brain power, and that translates directly into a faster, more responsive experience for you. It also means your battery lasts longer, and developers can actually pack more powerful features into their apps without you needing to run out and buy the latest, greatest hardware. Okay, to really get how this all works, we need to meet the main character in our story. It's a program that most people have never even heard of, but you and we use it every single day. Let's meet the compiler. At its most basic level, a compiler is just a translator. You see, programmers write code in languages like C or Swift or Java, languages that are built for humans to read and understand. But your computer or your phone, it only understands machine code, basically a long stream of ones and zeros. The compiler is the bridge that closes that gap. But here's where it gets really cool. A modern compiler does so much more than a direct word-for-word translation. A great compiler is more like a brilliant editor. It takes the programmer's first draft, and before it publishes it as machine code, it refines it, tightens it up, and finds all these clever ways to say the exact same thing, but using way less energy. And this isn't some secret new age technique. These principles have been around for decades. This book right here, known to pretty much every computer science student as the Dragon Book, is one of the foundational texts on how to build these amazing programs. It's just filled with the very optimization techniques that make our digital lives better. So, what are some of these clever editing tricks? Well, let's look at one of the most fundamental ideas. We'll just call it avoid rework. It's just common sense, really. Imagine you're baking and a recipe tells you to calculate 2 tablespoons of sugar times 4 over and over again. You wouldn't pull out a calculator every single time, right? You'd figure it out once, 8 tablespoons, and you just remember that. Well, compilers do the exact same thing with code. And this shows it perfectly. Look at the before version. The computer is told to calculate 4 times I 2 different times. A smart compiler sees that and says, no way, that's wasteful. So in the after version, it does the math just once, saves the answer in a temporary spot, and then just reuses it. It's a tiny change, but it saves real work. Now, there's a fancy name for this technique: common sub-expression elimination. It sounds super simple, almost trivial, but inside a complex app or video game, these little repeated calculations can happen thousands or even millions of times a second. So getting rid of them adds up to a massive performance boost. Okay, so let's move on to our next secret. It's one thing to avoid redoing work, but what about simplifying the work in the first place? We'll call this one tidy up. You see, the compiler can actually look at the code and spot any math that just involves fixed numbers, or what we call constants. And since those numbers are never going to change, the compiler can just do the math right then and there and replace the whole equation with the final answer. It's kind of like doing your homework ahead of time. Here's a perfect example. Instead of telling the computer to add 4 plus 2 every single time the program runs, the compiler just does the math itself. It swaps out the equation with the answer, a equals 6. Now, your device never even has to do that work. This simple but really powerful trick is called constant folding. And the tidying up doesn't stop there. Some math operations are just more expensive for a computer's processor. They take more time, more steps to complete. Multiplication, for instance, is more complex than addition. So another clever technique, strength reduction, can spot places where a costly multiplication can be replaced by a series of cheap additions to get the exact same result. It's all about saving precious processing time. So all these little changes, right? Eliminating rework, pre-calculating answers, finding those clever shortcuts, They all work together to transform a programmer's initial idea into something so much more refined and efficient. And the best part is, it never changes what the code actually does. When you put all of this together, it really does give you a whole new appreciation for the software you're using every single day. So what's the big takeaway here? First, that so much of the genius that goes into making technology great is completely invisible to us. Second, it shows that good code isn't just about making something that works. It's about how elegantly and efficiently it works. And finally, it's a great reminder that the device you're holding right now is constantly becoming more powerful, not just because of new hardware, but because of the sheer cleverness of software. And so, the next time you update one of your favorite apps and it just feels a little bit better, you can smile, because now you know it's not magic. It's the meticulous, invisible work of a compiler, just tidying up and optimizing, working quietly in the background for you. And that's a powerful idea to end on, isn't it? The technology we use every day isn't static. It's constantly being refined in ways we can feel, but rarely ever see. And that quiet, relentless pursuit of efficiency, that's really what pushes our entire digital world forward. I hope this gave you a new appreciation for all the invisible work happening behind your screen.